Hi and welcome to a brief tutorial on SAP HANA. So in this tutorial we're going to look at an overview of what SAP HANA is. We're going to look at some of the features of SAP HANA and why is it considered better than other databases. We're going to also look at the architecture of HANA and where it fits in the overall business scenario, and then we're going to look in depth into the Eclipse based HANA Studio, which is the application design tool of HANA to create information models. These information models will be used in the reporting layers to analyze complex data. So what is SAP HANA? SAP HANA first and foremost is an in-memory database. So that means that most of the data computations are done in memory instead of reading from the disk as in any other regular databases. So it's also a platform and it can be offered as an appliance or a cloud offering because it has an embedded application server in it, which is used for control flow logic, and because of that it's not just a database, it can also be called a platform. And then it also has a web server attached to it, which can be accessed via HTTP. So you can use HANA as an application in and by itself. So let's move forward and look at some of the features of SAP HANA. So the first feature, as I mentioned, is it's an in-memory database. All operations read and write happen in memory. And then the next one is column stores. Unlike in regular databases, the data in HANA is stored in columns. So this actually enables massive data compression, partitioning, and secondary indexes. Usually in regular databases, we have to go ahead and create secondary indexes, but because we use column stores in HANA, it already serves the purpose of secondary indexing. And then the next one is parallelism. So what is parallelism? How in HANA? It means that the different CPUs process data in parallel, thereby saving a lot of time and space, and really increases the performance. And then we have the other feature as projections. Projections is nothing but we choose only the data we need, or only the data we need to analyze. So we don't have to bring up all the data because we have in memory. It's an in-memory database, and you can perform operations in memory and get really good performance. So you can only choose whatever data you really need. Then comes the dynamic aggregation, which means that we don't have to have any aggregates on them. So what does it really mean? So in BW and other applications, we have to compute the totals and store them in aggregates. So what happens is you have to spend a lot of time filling those aggregates, and a lot of space which requires to store the data in aggregates. So we don't have to do all that in HANA because you can do dynamic aggregation. So you can do totals on the fly because of the high performance of this HANA database. So that's what it means by dynamic aggregation. So the next is active and passive storage. So what it really means is you only use the data which is active, like for current year, data can be in active mode, and the rest can be stored as in it's also called a cold storage. So you don't have to have all the data in memory. You only need to have data which is used mostly, like as I said, current year or current fiscal year. Only that data can be put in memory and used for computations. Then we have real-time analysis because of SLT, which is SAP landscape transformation, which is the table-to-table mapping in HANA, which enables us real-time analysis. And then we have SQL script, which can perform really complex calculations, and you can analyze data in a very complex way because we can use SQL script. So there are many other advantages of HANA as a database. It is the database SAP has come up with. And it has been built from scratch, so which means that you don't have to build on whatever is there. So since you're doing it from scratch, we have this column stores and parallelism and in-memory database, whereas the regular databases operate on row storage and reading from the disk, and not that much parallelism. So because it's built from scratch, they enabled and they incorporated all these beautiful features which really enhance the performance of HANA. So moving forward, let's go and look at what how HANA architecture looks like. So if you see the diagram here, this is basic HANA architecture. So here we see that we get data from the different systems, the SAP Business Suite, the SAP NetWeaver BW, third party. So we get all the data and incorporate it into the SAP HANA. And then we use reporting tools like SAP Business Objects, which is the official reporting tool of HANA, and then other applications will use the information models created on SAP HANA to have complex analyzing of data in the reporting layers. So as you see in the SAP HANA, you see that you have the in-memory computing engine, you have the modeling studio, which we will be looking at briefly shortly. And then we have real-time replication services, which I have mentioned about. We're going to look a little bit into the different methods of how we can get data from different databases into SAP. And then we see that we have the calculation and planning engine to perform the calculations, and data services is another way of transferring data from other databases to SAP HANA. So this is a basic architecture diagram of HANA. So basically what we're saying is we bring data from other databases into SAP HANA, which is which is a inbuilt application in and by itself. It has you can transform data and put it into SAP HANA. You have the application server, and the main feature of SAP HANA is most of the data computations are done in the database itself. You don't have to bring it to the application layer and do the computations there and send the data back into the database. Everything is done in the database, so that saves a lot of time, that saves a lot of storage, because you don't have to bring the data every time to the application server, every time you have to do a computation. So this is a very wonderful database. And so yeah, once you have the data in the database or in HANA, you have an ability to perform very complex analysis of business information using the reporting tools. So as I've mentioned before about how we need to get data from the database into the application layer, perform all the data intensive logic there, and bring it back to the database in a regular database, versus in HANA where you have the access engine, which is the application server, and it has this small layer compared to the database, because most of the database logic or the data intensive logic is done in the database, and we need a very small layer for a control flow logic. That's why the application layer in HANA is called access engine, also an extra small engine. The other name for it is extended services. So we need a very small layer for control flow logic in HANA. So that's why, and since the application layer is embedded in HANA, it understands the language of the database very much better than having another application layer physically put on top of your database. So what I really mean is the application server in HANA knows the database, the HANA database and the data types so well that it communicates better than if you have a regular database and you have to have a application layer bought on top of it. So that's the main advantage of HANA, because it better communicates. The application server of HANA, which is the Access application server, communicates better with the database. So moving forward, we'll see what SAP Native HANA is. So this is the same as what we have discussed so far. So Native HANA is nothing but you bring data into HANA from different sources and then build models, information models on SAP HANA, and then use them in reporting tools. So you're basically using the application server and web server of HANA for your application. So this is just an overview. We'll see a little bit more in detail in the later slides. So as you can see here, this is the native HANA XS, which is the extra small or extended services infrastructure. So as we can see, the database, the calculation logic is done in the database here, and then the control flow logic is done in the XS application layer, and the presentation logic is usually done in the client because of the way modern laptops and smartphones work. Most of the presentation logic can be done on the client devices, whereas the control flow logic, which is a very small layer, as I have said before, can be done in the XS application layer. So then if we move forward, this is like a little bit of detail into the SAP native HANA architecture. So as we can see here, we have different systems: SAP, non-SAP, and then the flat file. The flat files which are supported in HANA are the XLS and the CSV. So and yeah, we'll be looking at how to load CSV files shortly. So we get all those data, all the data from these systems into HANA using one of the transfer methods here. So SLT is nothing but the SAP landscape transformation. What it really does, it's a table to table mapping. So whatever tables are in a database, it maps one to one into the HANA database. So then we have the business objects data services. So this data services, we use this data services to transfer data as well. And then we have the DXC, which is the direct transfer, direct extract transformation, which is nothing but in SAP, we have SAP delivered data sources which are a replica of the database tables. So it's basically a structure where you can transfer data from SAP ECC to BW. So we are using those data sources to transfer data from the SAP systems into the HANA database. And then as you can see here, we build information models in HANA using the HANA Studio. And then the information models reside in HANA, and then we use those models in our BO and other reporting tools. And as I've said, BO is the official reporting tool of HANA. So this is a little bit of detail as to how HANA works. So this is basically what we do from end to end in SAP HANA. So this is native HANA. So what is non-native HANA? Non-native HANA is nothing but it uses the data intensive logic and this application server logic from HANA, but they also have another application server like ABAP or .NET or Java located outside of HANA, and they connect to these application servers by using open standard interfaces like ODBC and JDBC. So I put together a slide which shows us the different ways to upload data to HANA. So the first one, as I mentioned earlier, is SAP landscape transformation, which is a table to table and real time. And then it's the business objects, business objects data services. And then it's the DXC, which is the direct extractor connection, which uses the standard data sources of SAP, which it used to transfer data from ECC to BW. So we use those data sources to extract data from other systems into HANA. And then, as I mentioned, flat file is CSV or XLS. Moving forward, let's look at the advantages of SAP HANA Extended Services application layer. So mainly it's used to broaden the implementation base. So instead of just the database, we have the application server, so which is an added advantage. And then it enables application development, and then it also enables HTTP based user interface, and then better performing applications due to, as I've mentioned, deeper integration with database itself. And then it runs on SAP HANA, which is a very good database, and then we don't need any external application server unless we have something up and running and we want to connect it. We don't really need another application server to have an end-to-end application. So moving on, I have a small slide on BW on HANA. So what it means is it's a non-native application. So how it works is here we can see that Oracle is connected to BW in an original scenario, and what we do is we transform the Oracle database into SAP HANA using one of the different methods we discussed before, and then we upgrade BW to whatever the current version is, or whatever version works on HANA, and then we connect the SAP HANA to BW. So all your models will be, your BW models will be there, but you're just using the HANA database, which is a much better database than the regular databases, and you connect that HANA to BW, and you still use your BW as well for your modeling and reporting purposes. So this is a small scenario for non-native HANA. So moving forward, we have the SAP HANA Studio. So what is SAP HANA Studio? So it is an Eclipse-based application development tool in HANA. So here is where we go and develop the information models. We have different perspectives here. Perspectives are nothing but roles. So we have the modeler perspective, developer perspective, administrative perspective, debugger perspective. So according to whatever tasks you're performing, you go into one of these perspectives. There are a whole list of other perspectives as well, but in this tutorial we'll be mainly dealing with the modeler perspective and create different information models in HANA. So as I've mentioned, it's an Eclipse based tool, but we have also some plugins added into the Eclipse based tool to perform in a way we want HANA Studio to perform, and we won't be discussing that very much, but if you go into the development perspective, that's where we see the functionality of the plugins in HANA Studio. So in the HANA Studio, we will be designing an attribute view, analytic view, and calculation view. But before that, we're going to also create some tables and load some data from a CSV file into those tables, and then use those table data in our information models. So that's what we're going to do in this tutorial. So once you log into the system, like I did, I went to my Eclipse shortcut after installing the Eclipse based HANA Studio. You click on it, and this is the studio. This is how the studio looks like. I actually have my modeler perspective open. If not, you can just go ahead and click on the small button here and add your perspectives. You have a whole list of roles or perspectives which you can log into and work on it. So in our tutorial, we'll be only working in the modeler perspective. So once you log into the modeler perspective, so these are all the so this is my system here. So how I got connected to that system is there's this small icon here which says add cloud system, add system, or add system archive link. So I did a add system here, and I added my system, so giving all the credentials. So once your system is here, you see that it has like 4 folders: the catalog, the content, the provisioning, and the security. So what is under the catalog folder? So under the catalog folder is a list of all the databases that are connected to that system, list of all the systems, and then underneath every system you have option, like you have folders for every kind of database objects. And in our tutorial here, we'll be discussing on how to create a database table and load data from a CSV into that. So let's go ahead and create some tables. As you can see, this is my system here, and I have the tables folder here. So I just go right click and say new table. So once I say that, it prepares an editor for me to create a table. But the other way of doing it is I just go and click on whichever folder under whichever system I want to create a table. I just put my cursor on it and go into this small SQL console here. So I will look at it later, but anyways, this is the first approach, which is to just say new table. So here is where I give my table name. Let's say I want to create an employee table, so I'll say employee, and I can just go ahead and add the different columns in my table. So apart from that, I also need to mention under which schema Schema is nothing but a folder underneath which you are creating your objects. So I mentioned my schema here, and then the type. So we have an option to create the different kinds of tables, the column store or the row store. So in HANA you have an option to create both kinds of tables, row store and column store. But since we want to use the advantage of column store here, and we'll just say column store, and then you can just go ahead and add all the columns you need. You mentioned the data types, the dimension length, and if it's a key or not. So if it's a key, it always has to be populated. As you can see, if I hit on key, the not null is checked, which means that it cannot be null. So this is a simple way of creating a table. You add all your fields here, mention the data types and dimension lengths, and once you're done, you hit this small green button here which says execute, and your table is there. So for me to actually save time, I went ahead and did that, and these are the two tables I have created. So for our tutorial, we'll be using the age on demand over here and the order booking table here. These are both created by me, and if you can see, this is the definition. And yeah, for the age on demand, I had this file here, and I have account, entity, product, stage, setup fee, and all that. So that's what I've created it. And then my other one is the order booking one. So if I open the definition, I just created it based on this other file, which is just customer, entity, product, sales agreement number, and net price. So this is one way of creating a table. The other way of creating a table is just go under the table definition, or under whatever table folder underneath which you want to create your table under, and hit on the small SQL console here, and then you can write a code on in SQL to create a table. I already have my code here, which I'm going to copy, and once I hit the SQL console here, it opens the SQL editor for me, and I'm going to create paste my code here, which is nothing but a simple create column table code. Create column table, cust info, or amp info, first name, last name, phone number. So I hit execute, and it says, it has been created successfully over here. So if I refresh my table here, I should be able to see it underneath the tables, because that's where I have placed my cursor and said SQL. So it performs the SQL code underneath those tables. So my table will be amp info over here. So if I say open definition, so it should have first name, last name, and phone number. First name, last name, and phone number. So that's another way of creating a table. So you can either write a code or use the create new table and manually input your column names and define all your data types and data lengths and key and all those. So the next step is we'll go and fill these tables with our CSV files we have here. This is the age on demand, and this is the order booking file. So we'll go ahead and load these files into the new tables we have created. So to do that, we have a quick option here called import from the quick launch page in the modeler perspective. So we hit on the import and say data from local file under the SAP HANA content and say next. So here we specify the file, the delimiter, and if there are any header rows, which there are. So I'm going to just hit and say this is the file. It's a CSV, so it's a comma field delimiter. Header row exists. I want to import all data and ignore leading and trailing white spaces and file. And then there are two options here. One is to create a new table on the fly according to the source file being loaded, or you can choose an existing file. Since I've already went and loaded my tables, I'm going to show you how you can do a new table option. So I'm going to define which schema, under which schema I want the table to be created. And yeah, I select my schema here. Which is so I selected my schema and the table name, and I hit next, and it's thinking. So once it comes back with a table with the mapping table, which is this one right here. And as I've said, the source file has been mapped to the target file, and the data type and the lengths have already been recommended. If not, you go to this option right here and say one-to-one or map by name if we have selected an existing table before. So, and then here we can specify what is the key. So I've specified that account, product are my keys for this file, and then it shows me the file data here, a preview. I hit next, and it says that this is the data from the file which is going to be loaded. But if it is an existing table, it shows me the target file before and after. So I hit finish here, and now I refresh my tables to see the content. So this is the table right here, test session here, which we have just loaded. So if I right click on it and say open content, one more thing to mention is that while you're doing any loads, there is a small job log tab here where you can see the log. So my file loading was completed successfully, so that's why I'm able to see all the data here. So this is how you load a table with the CSV. We have seen how to load CSV into a table created on the fly, but if you choose the other option and do the manual mapping, you can load it into an existing table as well. So the next step is we're going to use these tables in our information models. So let's go ahead and see how we can do that. So in order to create any of the information models, all you have to do is you have to go into your content, create a package which is a simple name and description, and you create your attribute views underneath those. So this train one right here is my package. So I go and say new attribute view. So first of all, what is an attribute view? So there are three views which we are going to create in this tutorial, but there are many more other information models we can create in HANA. So the ones we are going to create here is attribute view, analytic view, and calculation view. So first of all, what is an attribute view? An attribute view is nothing but a view on two tables. You join those tables under some condition and you create a view. So, and you use this view in other information models, like you can use an attribute view in an analytic view or in a calculation view according to the analysis you want to do. And yeah, so it's basically a join between two tables. And one mandatory thing in creating an attribute view is you always have to specify a key attribute. That means there has to be a key for the view. So you can either, for every column in the tables under the attribute view, you can assign it as an attribute or as a key attribute, but there should be at least one key attribute. So okay, let's go ahead and name our attribute ATT test. If you just click on the label, it just copies the name to the label. And then if you see that the view types there are three view types. You can select either one. We are discussing attribute view now. So we click on attribute view and we have an option to copy it from a previous attribute view. And as you can see, if you click on that, the subtype gets grayed out because it copies the subtype from the copied from attribute view. So I'm saying don't copy from, just create a new attribute view. So it gives me an option to choose a subtype. So attribute views are basically three: standard, time, and derived. So standard is what we're going to discuss now. Time is where you can mention a time dependency, and derived is where you can derive it from previous attribute views, just that you cannot change it, like the option right here. So once you say standard and say finish, it opens an editor where you can create your attribute view. As you can see, it has opened up editor where I have my scenario workspace here, I have the properties here, and I have the details pane here. So once I go, and you can see that there are two sections for my attribute view. One is the data foundation and the other one is the semantics. So in the data foundation view is where I add my tables, which are supposed to be the part of my view. So I'm going to go to my schema here and under my tables, and I'm going to drag in order booking, and I have created another table called entity description here, right here. So I'm going to drag that as well. Why? Because this view is going to actually bring back the entity description from this other table and show me the entity description in my view. So it's a simple view. So what I'm doing is I'm joining the order booking table, which has all these columns right here, to my entity description table, which has entities and descriptions, and the join condition would be the entity. So whenever the entity matches, it just brings the description here. And the other option I want to show you is, so we have an output column here, and as you can see there are two folders. One is the column folder and the other one is the calculated column. So column folder is nothing but the output, whatever columns you want for your output. So how do you select those? You just hit this gray circle beside your column here, and it turns to orange, and it gets copied to this columns folder here, which means that it's going to be in your output file. So I'm going to hit products, sales agreement number, and net price, and entity description from here. So it's basically going to show me all the columns from this left hand table and the description of the associated entity from the other table. So this is a simple view, and once I specify my join conditions, I go into my semantics, and this is where I specify the type. So as I said, at least one should be a key attribute, and I'm specifying customer to be the key attribute here, and the rest would be like regular attributes. So once I've done that, I'm going to go, and I can go and save and validate here, or I can directly save and activate here. So I'm going to just hit save and activate, and then as I said, the job log tab here, it shows me the progress of the job I just run. So it does say that my job has been completed successfully. So what I can do is I can just hit the data preview button here and see the data. So there's one other functionality of an attribute view, which is a calculated column. So we'll go ahead and see that shortly. But yeah, as you can see, this is my raw data, and I should have the description for the entity here, which is right here, United Kingdom for UK. This is a simple view. And the other functionality is, you have an analysis tab here where you can analyze your data right here in the form of chart, a pie chart. So I can say customer and product, show it to me in a chart, or I can say a pie chart. So see, I mean, you can analyze the data in the database itself. Before, we have to do all this in the presentation layer, like in the business reporting objects and all that. But here we have an option to do it right here in the database itself, all the analysis we need. So going back to creating a calculated column. So let's look at our definition here. So let's create a calculated column based on a net price. So I want to mention to you that my net price in the file has been defined as a string. So I'm going to say net price star 1000 and hit a decimal here and say, I mean, in a calculated column, you can have this another option to create a new field based on whatever fields you already have. And you can use all these operators and functions here to create a new column. So I'm just showing you the functionality of that with a simple expression. So I'll say plus, since it's a string, I'm just saying add 1000. And there's a small tool here where you can validate the syntax, and it says valid expression. Okay, so I'm going to specify a length of 20 and scale of 2 maybe. Yeah. So I'm going to hit OK. So I have the net price here, and so the next thing I have to do is I have to go into the semantics and see that the net price has already been assigned a calculated column thing, so we don't have an option to select, unlike the before ones here where you have a drop down. We don't have the drop down here because the system already knows it's a calculated column, so it just puts it in there. So once you have done this, we can go ahead and see how our new calculated column appears in the results row. For that, I'm going to activate. So as you can see, the job log tab shows me that the job is running right here. So it did come back with some warnings, and all I had to do was change the lowercase to uppercase for the column description. For some reason it wouldn't take a lowercase, and I had to change the data type to a nvarchar. So those are the two things I did, and it has completed successfully. So now if I go and see my data preview, this is what I get, and as we can see, the net price 1000 is just adding 1000 to the string. As I've said before, the net price is a string in my file, so it's just adding 1000 at the end of it. So we again have an analysis tab here as mentioned before, and we can use the net price, the newly calculated column, to do our analysis right here in the database itself. So let's move forward and create a analytic view as well. So what is an analytic view? First of all, an analytic view is nothing but a view on several tables and attribute views. So you can have your attribute views and tables joined in an analytic view. So as in any other view, the way you create an analytic view is you go to your package and do a right click and say new and say analytic view. So, and it opens up this editor where you have three sections: the data foundation, the logical join, and the semantics. So the data foundation is the place where you can drag tables from your schema and have a mapping condition there. So this is my data foundation, and as you can see, the customer is mapped to account here, and I've selected all these fields for my output. And then if I go into my logical join section, I have dragged in one of the attribute view that I've created before. So in the details pane, I see that attribute view and the data foundation, which has all the columns that have been selected for output from the different tables. So here I can have a join condition saying that, okay, when the customer is equal to customer in the other attribute view, just give me all the different columns that I have selected. And then I can go into my semantics and have every column which are which are in the output, I can go ahead and assign if it's a measure or an attribute. As you can see, the drop down gives me two options, a measure and an attribute. So a measure is nothing but a quantity or an amount. Attribute is nothing but a characteristic. So according to your analysis and according to your data, you can assign each of that to your columns. So once you do that, you can save and activate and do a data preview, and it's the same as an attribute view. You get back results and you can analyze the data in the database itself. So one other feature is in an analytic view is that you can create a restricted column. So what is a restricted column? A restricted column is nothing but a column where you can actually restrict an amount field with respect to a characteristic or an attribute. So as an example, I can say, okay, show me the totals for US. So I can say, for that I can define it as totals, and I add entity equal to, so here is a small view of all my values for entities. So I say, okay, I select US. So what it actually does is it shows me the totals for US. I can add a number of restrictions here. So I can just go in and click in the drop down here and select, okay, give me the totals for this customer for who is in US. So if you click on the values radio button there, so it'll give me all the values for the customers. So I can select whichever customer I want to see my data for. So what it does is it only brings back data, or it only brings back totals for those entities and customers that have been selected here. So that is a added feature in an analytic view as compared to an attribute view. So let's now go ahead and see how we can do a calculated calculation view, and we won't be seeing any design for analytic view because of time. So let's go ahead and do the calculation view. So as in any other view, in order to create a calculation view, you have to again go to your package and right click and say new view, new calculation view, and it shows you a screen where you can select if it's an attribute view, analytic view, or a calculation view. So once you select a calculation view, you have the option to copy it from a previous view, previous calculation view, or and you also have to mention if it's a graphical or a SQL script. So graphical is nothing but what we are seeing now, but SQL script is nothing but writing code, writing a SQL script to define your view. And then the next one is the data category, which you have here, and you can mention if it's a cube or a dimension. A cube replaces the top node with an aggregation node, and the dimension replaces it with a projection node. So a projection is nothing but adding fields, as if you can remember, as I've mentioned in the earlier section. So for our example, we're going to just say Q because we want aggregation here, and just specify her name here. So I've already done that, and this is what I've got. So this is my calculation view here. So this is the definition of my calculation view. As you can see, we have different nodes here which we can use to analyze our data. So I've dragged in the projection nodes here, and I can add some tables here in a projection section or in a projection node, and that's what I've done. I went ahead and dragged in my order booking from my schema and I placed it there. And for my projection 2, I've added the age on demand table. So if you can see, my projection 1 table details are customer, entity, product, sales agreement number, and net price, and I wanted these columns as my output: the customer, product, sales agreement number, and net price. And as you can see, they are all copied onto my output pane. and then I go into my projection 2, which is age on demand, and I've selected account, product, and total here. So and then I said join these two projections. So I mean, according to however you want to analyze your data, you can use any of these nodes. So I said, I wanted to join these two tables based on the customer in my order booking table is equal to the account in my age on demand table. So I just joined it, and I wanted an output where I get all these fields from my projection 1 and the totals from projection 2. So that's what I've done. And when I went to the aggregation node, I've just selected all my fields, and like in any other view, I went to my semantics, and I have defined if it's an attribute or a measure. And yeah, and we can also measure the also have the aggregation set to count max or min if it's an integer. According to the data type it changes, and I've selected sum here because my total is a decimal here, but whereas my net price is an integer, so it gives me the count instead of gives me a count instead of the sum. Yeah, so once I've defined this, like in any other view, I just save and activate. So once I save and activate, it shows my job progress in the job log, and once it has been successful, I'll go into the data preview and show you according to my definition how the data has come up. So this is my data preview, and as I've mentioned in my calculation view, according to the join conditions of customer equal to account, there are only two customers which match the accounts in the age on demand table. So that's what I got back. If you can see here, so these are the two customers. But as I've said, according to your business scenario, however you want to analyze your data, you can use all these elements to analyze data in the database itself. So the next one is analysis. Here I can do an analysis of of my data. So as you can see, I've dragged the customer in the x-axis and the total on the y-axis, or I can do a shift here. But since there's only one or two customers, it's not that intuitive. But if not, you can really play with this analysis tab here and do most of your analysis in the database itself. So yeah, this is a small overview tutorial on HANA, and there are a lot more objects which you can design here, which I have not mentioned in the tutorial. But I think this small tutorial will be helpful for you to at least get started. So thanks for your time and happy learning.